And we are live. Hello, everyone. Hello, welcome. And let's see, first things, I think we are on screen and I would like to check the sound. So welcome, everyone. Hi, welcome to these workshops. Can you hear us all right? Please. I want to see thumbs up in the chat if you can hear us. Hello, hello. Loud and clear.
Hey, everybody. Morning, good evening, all that good stuff.
Can you hear David as well? Yes. Okay, so I think we can start. I should be already showing my screen. That's it. Okay, so welcome to today's workshop about building a multiplayer real-time game with Astra streaming. So a lot of things. And indeed, there is a lot of ground to cover today. So without further ado, let's start. I'm Stefano. I'm a developer advocate at DataStax. And yeah, I'm Apache Cassandra certified, and I love distributed systems, and I love to teach and communicate. So that's why I'm here. And today on screen, for the first time, we have David. David, tell us something about you. Welcome.
I'm David. Hi, everybody. I like to write code. I've grown up in the mostly the .NET ecosystem, but have been dabbling in Spring the past few years. I'm not going to admit any more than that. I have a focus of Pulsar message streaming, and I really enjoy that the technology and getting into that event architectures and that kind of stuff. I have a pretty long background, just generally with application modernization. Got a lot into Kubernetes, a lot of cloud native-ish kind of stuff. Thank you.
Great. So today, warm welcome to David on screen with us. And of course, you probably know that it's not only the two of us, but behind all of these workshops, this workshop and all the workshops we do, there is a whole team. And here you can see the whole team in all its glory.
Holy mackerel. Look at all this.
Yeah, a lot, right? You wouldn't tell there is so much effort in having these workshops going on, but there is, I can tell you. So I see, okay, so today we have a packed agenda. We will start by giving you a few practical information useful to follow with us. Then we will have a look at what are messaging systems. Why can't we just rely on databases in the good old sense? We will have a look at why storage also is still relevant for the game. We will then go more in detail and we will speak about Pulsar, or better Astra streaming in our case, which is the messaging system we will use. Then we will dive into how the game works, because today, you know, it's about a game that you will get up and running yourself. After that, we will wrap up and close and say goodbye. So there is a lot to do today. So let's dive in. First, I see Luca, I'm Italian. I'm Italian as well. So hi, ciao Luca. Someone is asking in the chat whether this is going to be recorded. We are now live, but yes, this workshop, as all other workshops by us, is going to be recorded. So don't worry, you can watch it later at your own pace, whatever. You can. We will give you many references and information to be able to go by yourself. But anyway, today you first attend with us this workshop, which is pretty much interactive, because it's not only just watching the live stream here on YouTube or on Twitch, in case YouTube has trouble. You will be able to ask questions on YouTube here on the side chat on YouTube, but also on Discord. Please, you are very much invited to join us on Discord for a couple of reasons. One is that once this live is over, the discussion can continue on Discord, and we can help you and assist you, and we can discuss over everything, etc. And the interactivity doesn't stop here, because we will also be using menti.com, Mentimeter, to ask you a couple of questions. during the workshop, and at the end there will also be a quiz with some prizes, so stay tuned. So today we will also be doing hands-on, and for that we have a lot of resources. We will give them to you throughout the workshop. There is source code and instructions, exercises, and also this very slide deck available on GitHub. Maybe it's a good time to give you the link so you can start opening it and be prepared. We will then use an IDE to watch and set up and run the code, which is an IDE in the cloud. So no need to install anything. You will just open a browser window and everything will be there. And this is Gitpod. And as for the backend that we will use, we will have a messaging system, which is Astra streaming, and it is based on Apache Pulsar. More on that later. And for we will also have a database that is a database built on Apache Cassandra, so a NoSQL distributed database that is also made available for you in the cloud without need to install anything. And this is going to be AstraDB. We will give you instructions on how to use them to create an account and create your own messaging topics and database later. It is all free, so don't worry. Now, once the workshop is over, there will be a bit of a lab. Maybe you can call them homework. There is a bit of exercise you will do, a bit of coding to do, and then you will be able to submit your work and get your badge. Today's badge is going to be about event streaming workshop. We actually have a lot of badges, and you can collect them all and use them to brag about and be happy. Okay, so how is it in the chat, David? All good? I see some...
All good. Everyone is very, very welcoming.
Oh, great.
A lot of eyes, a lot of hellos.
So why don't we try to get our audience a bit better with a few interactive questions? For that, I'm going to switch to another presentation that is the interactive quiz, and I will give you a code, and you will have to maybe open a new browser window, or even better, your phone. You will go to menti.com and enter the code that you will soon see on my screen and in the YouTube chat. So here we go. There. So you can enter the code that you see on the chat, you see on my screen. You can scan the QR code, whatever, and you will get to the questions. These questions are just here for us to get to know better, to get to know you better. And but please keep the window open, because later this will be the quiz itself. So let's see how many of you are joining. So I see more than 60 people watching us now. So please join us on Menti. By the way, we will ask you questions, but please do not answer in the YouTube chat, because, oh, maybe I better disappear, because I am absolutely over the code that you will need. Good point. So pardon me if I disappear. Yes, Sidiculous, same thing as Mentimeter. So menti.com is the site you as a player connect to give us answers. And the code is the one you see here on screen. Please look at your phone or whatever, but not at YouTube, because there is some delay in the questions, which is going to be important later when there will be the quiz proper. And do not answer in the YouTube chat, because that would be a wasted answer. Now, let's see. I see more people joining, and I think we can start with the questions. So I can maybe reappear for me, and here I am. Welcome back. Okay, so let's see. First question, where are you from? We are always trying to have our workshops in several time zones to meet the needs of everyone. And it's very nice, because it seems like we are covering almost all of the world. Wow, welcome some people from the Americas, Europe, Asia, even Australia. So we are really covering basically all time zones. That's great.
Yeah, great.
Welcome, everyone. I guess for some of you, this means being up in the night. So well done. Congratulations. I hope it's going to be worth, useful, great from Sydney. Okay, very good. Okay, so great. Hollywood. Let's go on. Okay, yeah, but most of you are from Europe and India. Hi, India. Yes. So now, a question. Did you know messaging platforms? Just a bit. Not at all. Very experienced. So we have someone who is very experienced at messaging platforms. Great to see you. Yeah, so many of you have no experience with messaging platforms. I hope today it will be a great first introduction. We will be using them and speak a bit about them. Of course, as David knows, the topic, and not a random word, the topic is very big and deserves a lot. But today we'll just scratch the surface, right?
Just because you're walking into this with what you feel is not much knowledge, don't feel like you're at a disadvantage. There's a lot of us. It's a new space, and we're all kind of learning as we go.
Yeah, definitely. Okay, so next question. Are you comfortable with a mixed stack made of Node and Python? Let's see. I can write code. I can read code. All new to me. Okay, that's good. I see. So no, I see many of you are familiar with those two languages. That's good because, well, 10x dev. Wow, welcome on board. Okay, so okay, today's code is actually in these two languages, but it should be pretty easy to understand, and also the little modifications required for the homework are very easy and guided, so it will be probably accessible to all of you. But you are very welcome to re-implement the game in a different language once you understand how it works, because today we are going to speak mostly about its architecture than the code itself. Have you ever used Apache Pulsar or Astra Streaming? Let's see, this is a relatively new, especially Astra Streaming is a relatively new offering, and Apache Pulsar also is a sort of a newish, still a new kid on the block in the realm of messaging platforms. It is what? It came out in 2016, if I remember correctly, which is still newish in messaging years. So ever used? Perhaps. Someone says perhaps. That's an interesting answer. Anyway, okay, so there is someone in the chat who knows C# better than Python. David, this is for you.
Oh, Luca, we are kindred souls.
Oh, great.
I'm right there with you.
Okay, so it's good because altogether we cover a lot of different languages. Great. Okay, so I will stop the quiz here because these were just questions to warm you up. But keep the connection open to Mentimeter because later here it will be the quiz. With that, I will just switch back to my presentation and I would say it's time to start for real. And so let's start with the content. Okay, so messaging systems. Why shouldn't we just use a database? Well, it depends on what is the goal. We have a game. We have a game that we probably would like to have. Sorry, I think I might have some streaming problem. Pardon. Okay, it's all right. Somehow my window froze, but everything is working. Okay. So we are trying to build a multiplayer real-time game. So this is probably the architecture we are after. At least this is the most reasonable architecture I could come up with. There are several clients, clients of some kind, and they are all connected to a big server in the middle, and they exchange information. Now, don't mind the picture I use for the clients. If you don't recognize the things at the periphery of this picture, then congratulations, you're young enough not to remember what was gaming in the 80s. These are very big gaming consoles as they were back then, and they're probably bigger than your fridge now, but don't worry, this is just a picture. Anyway, these will represent our clients, and each client will have a player, a human playing the game. So these are all connected. Yes, Pong. Well, Pong is even earlier. I think Pong dates from the 70s, if I'm not mistaken. But yeah, you know, the 80s. Yeah, exactly. Pac-Man, you know. Okay, but anyway. Players will be using those client machines, and each one of them will be connected to a big central server, which will receive information from the client in the form of updates on the state of the player. So an action such as move to this position or whatever. And in return, the server will send around updates on the state of the world, which is ultimately needed for the client machines to represent on screen the new state of the world. So that's, in essence, that's what a multiplayer game needs to do. Okay, so let's look a bit more in detail at how messages, how data flows in this architecture. The client sends something to the server. Let's say the player moves from position X to position Y. The server might store this information somewhere, and then what? How do the other client get this information and get updated? So in the old days, all you could do was to have every other client constantly ask the server, what's new, what's new, what's new? So you ask the server what is new, and you wait a bit. Then you ask again and you wait a bit. And that is basically what was called polling. So periodically asking the server. But it's really something that is not ideal, because, I mean, this is what you could do with a request and response architecture, right? So the only thing you could do, and so someone raises the point that the stream might be stuttering. So let's see.
Yeah, let us know if there's if it's not coming through for you.
Okay. Let's see. Can you hear me? Can you watch us? Maybe you might try raising the resolution, no stuttering. Thanks, Rags. So you might try refreshing or changing the video quality maybe. Okay, so back in the time, all you could do was to have client-initiated request and response. But that is really not ideal, because you have a lot of overhead. You have to initiate a new connection every time. You have a lot of headers going around, really useless headers. And the more often you ask the server, the more you are wasting your time, because it's more likely that the request will not return anything new. So it's a catch-22. Either you go more frequently, but then you waste more request for nothing, or you go slower, but then it's really not real time, right? So you have latencies and everything. So it's really a mess, ultimately. Luckily, this is something we have left in the past. And what we would like is to make, without the request response paradigm, no polling, and just have the server push new data when it is available. So we want, like in this picture, right? We want the client sends a new piece of information to the server, which immediately gets routed actively to the other clients, to all clients, probably. So we want a server-initiated communication. And for that, we need a messaging platform. So something where the server actively reaches out and sends out pieces of information of any kind. In essence, this is a defining feature of a messaging platform. Now, before we go further, I would like to make one thing clear. When I say messaging system, I do not mean like WhatsApp or whatever. And when we say streaming, we do not mean, sitting on your couch and watching a film. So messaging system or streaming systems, we mean backend services that are made and they are optimized to convey, to dispatch and route data between other backend systems, usually, or maybe also with clients, but usually between backend and backend. And this data is usually made available in small pieces as time goes by. So it's progressively available. And this data is routed around as it comes available. And this is as opposed to, sending out the bulk thing when it is completely ready. Of course, this definition of streaming has much to do with, watching a video, because you're now watching us live and the video is not over yet. So you're actually receiving small pieces of this video as it becomes available. So this is really an application of streaming, is watching us on YouTube. So congratulations, you're doing streaming. Well, okay, so David, any news from the chat? You want to add something?
No, everybody is enthralled with Rag's.
Yeah, I see the chat is on fire and you are playing with Nightbot. So you finally fixed the bug with UR. Very good. Okay. Okay, so back to our topics. There were various reasons why streaming platforms became a need and came along. One is that there was a need in IT, in data technology, there was a need for non-blocking communication. And this was in response to the good old paradigm of remote procedure call. That was the original way to communicate between backend services. The other related need is the need for pushing data instead of pulling data. So you've seen the original idea of polling was the client always keeps asking for new data, but sometimes the server wants to actively send out new data as it becomes available. So it wants to push data. The other very important reason is that we want to decouple the sending out of the messages and the receiving of them by other actors, which is very much tied with a microservice-based architecture. So we want to have loosely decoupled parts that are able still to speak together. And this is basically the essence of it. So we want platforms that make it possible to receive and deliver messages in a sort of loosely coupled way. By the way, once you have these messaging platforms, you can start thinking of every part being written in a different language. So you can really start replacing parts independently and doing, this microservice kind of approach. And this is yet another way to get out of the monolith curse, so to speak. So messaging platforms in the modern sense usually act also as buffer for communication, because if usually, okay, when I say messaging platform, I imply that those are message brokers. So they are not just ways to enable communication between a sender and a receiver, but they are also a third part in the middle that makes it so it stores messages so that it acts as a buffer. So if in that moment the receiver is not able to receive anything, then this broker is able to store the message, and then whenever the receiver is back available, the message will be delivered. So this is really a decoupling also in time, if you want.
If I could,
sure.
Stefano, a good way to think about this, especially when you're in a microservices environment, microservices, each one is a different domain. They do different things, and inherently they run at different speeds. Right, the speeds could be request response, the amount of information it's delivering, whatever it may be, but they usually run at different speeds. And if you're trying to get two microservices to talk to one another, you're of course going to be the slower of the two speeds. That's going to be as fast as you can go. If you put a message broker in between them, then you can sometimes overcome these things. Or you can think about logging, right? Every single microservice out there is emitting just all kinds of logs. They all seem to be pretty chatty. You don't want to wait for that. You just want to send the log off and move on, because that shouldn't be a part of your response time in getting back to your customer. And so that kind of thing you can just send off, but you also don't want to lose the log, right? So you can't just fire and forget it. You could send it to a broker and let the broker decide either I'm going to deliver this somewhere successfully or I'm going to put this somewhere so somebody else later on can say, why didn't this make it to the right place? It gives you some nice options there without holding up your response times.
Yeah, good point. So in general, you can really flexibly change every part of your messaging passing architecture. Okay, so the good news is that these are golden years for messaging services. Let's say that if a few years ago it was the hype was on NoSQL databases and big data, maybe today the attention has shifted to messaging, so to data in motion as opposed to data at rest. Indeed, we have witnessed the birth of very many messaging systems, most notably, well, RabbitMQ, Kafka, and Pulsar more recently. Kafka is probably still the most popular and the most widely used. If you have used a modern messaging service, you most likely have used Kafka recently. And we will probably see more going on as time goes by, because this is really a hot topic, and it's, in a sense, an absolute need for every data-centered enterprise today. So what are the various use cases for messaging? Well, in many real-life applications, the data set is just never complete. So you can't say, okay, this data set ends here. It's just coming more and more data. So unless your company, let's say you're collecting clickstream information from your website, unless your website goes out of business tomorrow, you will always keep collecting new and new data points. So your data set is really never complete in a meaningful way. So you might think of batch processing for analytics, but it's you that arbitrarily sets the boundaries of these batches. And this might be undesirable. So you might want to, let's say, make the batches smaller and smaller and smaller and have more and more small analytic steps, which in the limit brings you to a continuous analysis, which is what streaming is there for. So you have a lot of different cases where you just have new pieces of data, usually small pieces of data that keep coming in and in and in. So it is IoT, self-driving cars, finance, social media, online gaming. So all kinds of real-world situations where you just see pieces of data coming in and in, no end, in an almost continuous way. So this is really something that fits very well with messaging, much more than just databases. So in a very general way, how does a messaging system look like? Well, this is this blue thing in the middle of this scheme, a messaging system, and in particular, this might be a message broker, so something able to retain messages and deliver them later, probably. A messaging system is connected to producers on one side, which just keep a connection to it and keep sending messages, so small packets of data of some kind. And on the other hand of the messaging system, there are consumers, which keep a connection probably, and keep receiving these messages as they become available. Then there are all kinds of subtleties. So if the delivery is asynchronous, then then you need message brokers, so something able to retain messages in itself. So this is this asynchronous property we saw earlier. Then you can have various ways of delivering the messages. So you might want a guarantee that every message is delivered exactly once or at least once, and these are usually tunable properties of the messaging, of the way messages are delivered. And they all come with a compromise between performance and the amount of guarantee that you can get from the messaging system.
Hey, Stefano, if we could, for the newer folks on this, for just a moment, I'd like to kind of double click on the idea of an event, because that's kind of maybe a new concept, right?
Yeah, right.
What is an event, right? Because an event could be interpreted. The way I like to think about it is think about creating a new account, right? Just about everybody in every system at some point has to create a new account. To create a new account, there are quite a few steps that usually have to happen, and there may even be synchronous steps. So the request coming into the system from your like API client is create a new account with a big payload of here's all the information about the account, maybe here's some billing information and whatever. But once it gets into your system, that endpoint is then going to break that up and say, okay, first I need to create an ID. Then I need to check for the account to make sure it's not already there. I need to check this, I need to check that. I need to add billing information. I need to validate the credit card information. All of these things have to happen. Some of them can happen asynchronously. Some of them have to happen synchronously after one or the other. Each of these actions would be an event, right? And so think about just the billing side of it. You need to validate the credit card. You don't want anybody else to do anything until the credit card information is validated. Once it is, then you need to notify, or whatever event is actually doing the credit card validation. Then you need to come back and tell your endpoint, okay, credit card's validated.
Yeah.
And there's also a billing system that wants to know about that the credit card's been validated. And all of these are consumers, right? About this one little event of a credit card's been validated. So that's like when you're thinking about these things and you're thinking about larger actions within the system, like creating an account, pull them apart into granular bits, and those are probably going to be your events. And then the consumers are other systems and other services that want to know when those events happen.
Yeah, good point. Speaking of that, we can highlight two main patterns of consuming events or consuming messages, events, pieces of data from a topic in a message broker, in a message system. We can look at, we can look at the queuing message consumption pattern, which is very used, and it fits a typical use case, namely a list of items to do. So let's say there are some pictures to be resized or whatever, some heavy processing tasks that are piling up in a to-do list. And you can have several consumers sharing the load. So we want every item of the to-do list of, so this topic would contain a series of items to be processed. And we want several consumers to share the load, and each one take so they will share the messages so that every message goes to exactly one consumer, because you don't need more. And this is a typical way is to use a topic as a shared queue of items to be consumed by exactly one consumer. And a sort of opposite approach is the pub-sub consumption pattern, which is very different. And basically it works like that. There is a series of events being produced in a topic, and there are several consumers, and each of the consumers needs to get all events in the topic. So think about what is happening now in this YouTube Live. Every atom of information making up this video is going to the topic that is this YouTube video, and every one of you who are following us will need to get all of them to be able to see the video. So it's really like tuning on a radio station, and every one of the consumers will start receiving messages the moment they connect to it, they subscribe to it. And if you think about it, that's very much what we need for an online game. So let's say the server will publish every change in the game world to a topic, and every new player who starts joining the game will start getting all messages, all events expressing changes in the game world from the moment they connect. And this is exactly what we need. So we need a pub-sub or publish-subscribe pattern in the game. So these are the two main philosophies in a sense, and then there are several subtleties and several subtypes of messaging of patterns for consuming messages in a streaming system. But an important point is that what we need today for the game is a pub-sub way of consuming messages. Now, before moving to the next section, I want to stress an important point, that is, databases are not messaging systems. That might sound trivial, but it is a very important distinction. And the main point is that databases are concerned about data that is sitting there in the tables, ready to be reached, to be queried. And the data is sitting there quietly waiting for us to query it, while a messaging system is about data in transit, data in motion, constantly in motion. So in a database, we have tables or collections. In a messaging system, we have topics. Usually topics, you can think of them as long pipes with two ends. One end to put messages in and the other end to get messages out. But then again, between databases and messaging systems, there are unclear boundaries because of various reasons. One is that messaging system needs to have some persistence because they have to store the messages at least for the transient time before they are delivered. On the other hand, many databases are equipped with what is called CDC, so change data capture, which is a way to offer a stream of changes in the database status. As the database changes, you can tune to this CDC and get a stream of updates that is then enough to reconstruct the current status of the database. So this is actually not a clear distinction. It's more about how is the storage and the working of the architecture optimized for. If it's optimized for, let's say, keeping data for a long time, making it accessible in various ways and keeping it stored there, it's a database. If it's optimized to make delivery fast and not so much for funky access patterns other than sequential access, probably it's a messaging system. Now that's, yeah. So as Alex is writing in the chat, a typical data-based system of today needs both. So you need a clever way to pair the two. And indeed, today's game is also doing that. So, okay. Indeed, let's speak very quickly about storage because we want, if you had a storage layer on top of the streaming of the messaging in the game, you make it richer. What do I mean by that? Well, think about a game where the server is just routing messages around. So it receives messages from a client and makes those messages, routes them to all other clients. And these messages are what? Updates on the state of the game. So a player is at that position, a new player came in and stuff like that. Well, this is a game, but it's not particularly rich because the representation of the whole world of the game is living in every client memory, and that's it. So there is no real way to, have server-side validation of stuff like collision between players or whatever kind of meaningful interaction. It's just that. But if you add a storage system on the server side where the real memory of the current state of the game is stored, then your server side might do some fancy things. It might validate a player move against its knowledge of the current state of the world and forbid you from walking into a wall. Or make it possible for you to, eat another player or whatever it needs to happen in the game. And that's possible because the source of truth on the game is now on the server side. That is not to say that the client is not building its own representation of the world, but this is what is now gray in the picture. This is just a secondary thing. The real source of truth is now on the server side, and it is persisted in a database. So this is why we also need a server-side storage. And now, I'm afraid we don't have much time because this might be a topic I would like to go more in detail on, but just to give you an idea, messages, you see, look like each message might look something like player A is now in this position, or player B has entered the game, or there is food now at this position, and so on. So it's just a stream of point-like updates. While on the database, you have a table that is just a map of coordinates, and at each coordinates there might be something like an obstacle, a player, and so on. So these are two different ways of representing the world. Actually, if you now that's important. If you had knowledge of the whole history of messages from the beginning of time, you are of course able to reconstruct the current state of the game, the current content of the database table, right? And this is indeed the principle behind the event sourcing that takes this philosophy at heart, and it's based on the idea that the source of truth is the sequence of messages, and the current state is just, a consequence of that. So this is, in some application, it is a legitimate way of looking at things. Now, this formula is a bit of a informal way of saying that if you pile up all messages that you received from the beginning of time, you are able to reconstruct the current state. Sometimes there is no actual explicit current state at all. It is just in the memory of those who consume the messages, and that's exactly the idea behind event sourcing. Today, the game will actually have a table hosting the current state because that's useful to have for server-side validation. But still, I mean, the relation is that from the sequence of messages, you are always able to reconstruct the current state of database, while the opposite is, of course, not true. From now, you can't reconstruct the whole of history, right?
But there's everything that Stefano said, realize that there are two key things being used here. One is storage and one is compute.
Yeah.
Right? The messages that you're looking at on the right there of that slide, that's memory. That's compute, because I just got to process those things and make sure they're always flowing and always happening. But then you have a storage of those messages into a table, right? And the storage, as we know, reads and writes to a database is very expensive. And so if you try to have some super fast multiplayer system, constantly writing to a database ain't going to happen, right? And so I think what you're going to see as we go on here is one of the strengths that you're going to find in Pulsar. And probably the reason that all of us, when we met Pulsar, we were like, oh, this is cool, is because Pulsar is one of the few messaging systems that makes the distinction between compute and storage. And I don't want to take Stefano's thunder here, but keep an eye out for that. Yeah,
very good point. Unfortunately, we only have 2 hours and we have to do all of everything. So many very interesting topics will be squeezed in a corner, but thank you for pointing them out, because there's so much and it's very hard to give everything the right importance it deserves. Indeed, we have to move on and go more in detail with Pulsar and Astra streaming, because we've been speaking in abstract about messaging systems and whatnot. Now, today we are going to use a specific messaging system called Apache Pulsar, and in particular, we are going to use Astra streaming, which is basically an offering of Apache Pulsar as a service in the cloud. More on that. So let me make a small forward. Messaging systems, especially when they are distributed, as you probably want them to be, are very hard. They are very hard pieces of software. You probably don't want to write your own, for sure. And even if you use a ready-made messaging system, operations sometimes are very hard. So everyone who tried to repartition a Kafka setup knows that nothing is easy there. That's why today we rely on a managed solution, so you don't have to worry about that, right? So today we are going to use Apache Pulsar in the form of Astra streaming. So Apache Pulsar is an Apache project born at Yahoo and promoted to the Apache Foundation 5 years ago or so. It supports PubSub, which is what we need, so publish, subscribe. And it actually has a lot of nice features. And as David said, it splits compute from storage, which is a very important point of strength, especially when it comes to repartitioning and scaling and operations. And also when it comes to robustness and failure tolerance. it has a lot of modern features that we probably won't have time to go much in detail into, but it also supports SQL built on Presto for querying data hosted in Pulsar. It supports functions to embed routing and filtering within Pulsar. It supports I/O, so you can have sinks and sources to connect to other data stores. It is actually a very powerful and articulated messaging platform, and all of that is offered in the cloud as a service within Astra Streaming, which ended its beta yesterday, so it's now general available, and it is still absolutely available for free with a generous free tier. So today we're going to create a Pulsar topic for free within your account in Astra. I don't know, David, if you want to add something, because that's probably more your topic, if you want to.
Yeah, I would say that if you get into spinning up an instance of Pulsar, and so an instance is, they're going to also call it a cluster, a Pulsar cluster, but basically I want to run Pulsar. There are Helm charts out there that'll do the trick. They attempt to be everything to everyone, so it's kind of overwhelming at all the options and everything. There are so that would be in like Kubernetes or something. There you could just spin up the each of the Docker containers. There's that too, but there's a lot going on. As Stefano said, there's a lot of moving parts here, right? And so the idea with Astra Streaming is, look, I want to focus on messaging. I want to focus on getting this done in my application in the right way to do it. I really don't care about the infrastructure right now or the services. I'll get to that later. And so this kind of really is a quick on-ramp to like, give me it for free. Let me go messaging.
Yeah, that's a very good point. Okay, so very quickly, as David said, there is something called a Pulsar cluster that is, let's say, the big installation to make it easy to understand. And this is multi-tenant, meaning that within that one cluster, there can be several tenants. Each one will never know of each other. So one of them is going to be you. So you will be a tenant, which here I call game server, whatever. And just to outline the structure, within a tenant, there might be several namespaces. One of them is default, and it is default, ready-made for you. Within default, there might be several topics, and each topic is this pipe routing, this pipe where messages flow through. So one of the topics, we might call it word updates. So there is a tenant, again, a namespace, and a topic. Indeed, to give the full name of a topic, you see it on the upper right. You see there is tenant / namespace / topic name. And the prefix persistent hints at the fact that you can actually have topics that are persisted on disk and other that might be just volatile in memory, which is, again, a sign of how you can customize the performance and the safety of your Pulsar usage. Because, of course, if you persist on disk, you are more safe against certain kinds of failure, but you lose a bit in performance. But that's just up to you. I mean, there is a lot for fine-tuning. Okay, so that being said, I probably have to skip about some internals of how Pulsar works. Let me remind you that all of these slides are available in the GitHub repository. And speaking of that, let me drop the link to the GitHub repository again, because it's now Nightbot data. Rags, thank you. Great. So something that I'm not spending words on today is the database part. That's not because it's less important. Indeed, we are going to use another service within Astra, that is AstraDB, which is a NoSQL database built on Apache Cassandra. And this is going to be the persistence layer we store the game word on. There is, of course, no time to do everything, so we will have to just take it for granted. There is a database. There will be a table, and it will host the game data. Please go looking in the README for more details, and there you will also find many starting points for exploring more about the database side of things, which is, of course, not the main topic for today. I'll just add that we have a lot of workshops focused on the database part. So you're very much welcome to join us for other workshops, or just look for them and watch them asynchronously on YouTube, or just go looking for the README in the GitHub and ask us on Discord. So, okay, with that, we are going.
Excellent,
Sorry,
Stefano. Excellent shameless plug there. Awesome.
Yeah, we know how to do things. No, okay, of course, this is. By the way, I see a few names that I recognize from the bootcamp we did in January. So, hello, I see a few names there. So it's nice to see you again. Okay, so let's go and create a few things in Astra. So first thing, you should see chat. It is going to be, okay, so let me first jump to the GitHub repository. So this is today's repository, and it contains everything, and it is designed to make it possible for you to just follow it without watching us and just do everything and learn everything. So I will skip through it, but you see there are instructions, there are introductions, prerequisites, the slides themselves, information for the homework, more on that at the end. And let's jump right in and let's go to create your Astra instance. So there is this big orange button. Maybe I can jump to the demo view, which is very fancy. And that, David, I'm sorry, that will make ourselves a bit smaller on screen, but content is king, as they say. So
yeah, everyone is sick of looking at us anyway. It's okay.
And they know our faces by now. So, okay, so there is this big orange button, Create Astra. If you click on it, maybe in a new, open it in a new window, you will find such a window looking like this one, where you can register either with GitHub, Google, or by name, email, etc. And this will be how you make an Astra account. It's free. There will no ask for credit cards or anything. You just register and you will start using Astra products immediately. So for free, I remind you, there is a free tier, and that covers both streaming and database, up to quite a high monthly allowance. So just go ahead, you register here. Of course, I already have my account, so give me time to log in. So please start by registering here, name or whatever. You just click with GitHub, whatever. So,
and no, there's no credit card required.
Absolutely not. Let me log in.
Wow, look at that. That's a fancy email address.
Yeah, it's actually one of my secondary aliases. Okay, so I got the wrong login, I think. I wanted to use the other one because I have several aliases. But
all these aliases,
that's okay.
Stefano,
yeah, but that would give our friends here time to register. Actually, you will be surprised at my other alias. Okay, here we go. So this is have I already mentioned that I don't like Windows? Okay, so this is how it looks like when you first register. So you have a dashboard here, and you should see databases and streaming. Now I'll just follow the instructions I find in the GitHub repository, and the first thing to do is we have to create a streaming. So let me show you this create streaming button. So let's say you are registered and you are entered your Astra account and it's empty like mine, right? So you first create a streaming, and this is done with the button create streaming here on the left. Let me click on it. I reiterate, all instructions are in the GitHub repository, very clearly spelled out. So we have to create a streaming and create a database, right? So let's start with the streaming. Tenant name. You remember that the tenant might be something like game server. I'm pretty sure this will be already taken, but anyway, let's try. So game server, And then I choose a region. I'm in Europe, so I go to Europe West, whatever. So, oh, look, game server, tenant name is already in use, of course. So tenants need to be unique across the whole cluster. So let me call it game server 44556.
And in the corporate world, you could think of a tenant as maybe different areas of business, right?
Yeah.
Don't think of it. You'd be tempted probably to think of it as different applications.
Yeah.
But in fact, it's a broader view than that, right? Maybe the company has an application for HR things, and it has another application, HR management, and another application that does I don't know, payment processing or something.
Yeah.
Right. And so those would be different tenants, because then you're going to get to the namespace to do, finer grain distinguishing.
Yeah. Right. Good point. Okay, so anyway, I choose my tenant name and I choose my cloud provider and region. I'm not sure, you probably can choose also other providers, but I'll stick to Google Cloud and Europe West. So maybe I should be good to go. I don't know why this is now not available. Looks like. Here we go. Maybe there was some kind of glitch. So if you hit create tenant button here, your tenant is going to be created. Now, let me just write down in my notepad here my tenant name just for future reference. And I suggest you to do the same. So we will need this data later when we will tell the game to connect these. So I just keep a few pieces of information here in my notepad, but let's go back to Astra UI. So far, we created a tenant and we have to create a topic in it, right? So, so your tenant name will be probably different because the names have to be unique. So don't forget that. So we have to create a topic. And one of the ways is to go to the topics tab here. I go to topics, you see, and probably there will be no topics yet. We will not create a namespace. We just stick to the default namespace to save a bit of time. But there is this nice button, add topic here. And if you click on it, you are able to create a new topic. Now, I'll call my topic word updates, and I strongly encourage you to do the same, so we don't have to change anything in the code setting later when we want to run. So please call it word updates and just click save. It will take a little bit of time, and let's give it time to completely finish creation of the topic. We should be good. So maybe I might have to refresh. Actually, that's possible, but I'm pretty sure my topic is being created now. Let's give it a little while. So if I do refresh, I should be able to see my topic being created. And it's probably still being created in the background. We actually observed this slight delay of 1 or 2 minutes in already. Maybe I can navigate away and come back to it. Okay, so let's.
So as he's doing that, remember, just to reiterate kind of the hierarchy here, because every message broker has different words for this, but just about all of them are pretty much accomplishing the same thing. In Pulsar, you have a tenant. The tenant has a namespace, and then a namespace has topics on it, right? So you gotta keep that clear, because it's going to build a URL-ish thing for connecting, and you have to specify all those.
Yeah. So in the meantime, I switch to.
Which tenant 2 in your slide there is scaring me. He looks like he's up to no good.
Yeah, but this is actually, I added that picture to stress the fact that in a sense, you don't have to worry about what other tenants are doing, because this is really an impenetrable wall between tenants. Multi-tenancy also contains that fact, so you don't have to worry about interference
Might just go for it. Go for the topic again.
Yeah, so I'm pretty sure that has been created, because if I recreate it with the same name, I'm pretty sure I would get a error. This topic already exists. So I'm pretty sure the topic exists. It's just probably an UI glitch that I'm not able to see it, which is a bit unfortunate, but we probably can.
So you can have the
Let's come back to that later, maybe.
Yeah.
Okay, so let's assume you created the topic for a second, and then we come back to it later. And we will look at this later. So in the meantime, while we give time for the topics to the topic information to be propagated to all layers of Astra, let's move to creating a database, which is a similar operation because, and okay, so I was a bit fast. You see in this left menu here, you have databases, and there is a nice button, create database. Click on it, and in a very similar manner as you saw before, you saw for the topics, you can create a database. Again, I suggest you to call the database workshops, and the key space Drapetiska, which is a funny name, but so maybe I can paste these here. DB name workshops, key space name Drapetiska. So what is a key space? Well, a key space, we don't have time to delve into the internals of Cassandra or AstraDB, but the key space is a group of tables. Today we will need just a single table, and it will be created by the game as it starts at that, so you don't have to worry. And what is Drapetiska? Well, Drapetiska is a species of spider. So European spider, very tiny, very easy to miss spider. What I maybe should have mentioned is that I like spiders. So I built the game around spiders, but that's
a key point.
Yeah, a key point maybe.
Thank you.
Okay, so database name workshops, key space name Drapetiska, and then again, you choose a cloud provider and a region. Again, I'm in Europe, I'm going for GCP and Sangisland. I suggest you to stay on GCP because the other providers, while they are free, they still require you to ask for them being activated for you as of now. So please stick to Google Cloud and then choose an area and a region, DB name, key space name, area region, and then create database. Okay, so now you see this database called workshops is now pending here. You see it in your dashboard. It's being created. It's been provisioned. That takes a couple of minutes. And while this goes, let me go back to streaming just to check topics. And still, I don't see topics. That's very unfortunate. But we can assume it exists, and let's see how it works later. There we go. So it just required a bit of waiting and refresh. So, okay, so now we are in the situation, everything has been done. Database in status maintenance. Okay, so probably it will, Sushant, it will probably be a couple of seconds or 30 seconds because you probably have already your workshops database and you just created a key space, and it will be available very soon, I think. I still can't see the topic, so let's go forward and we will come back to the topic later. So anyway, I ask you to bear with me and then come back to the topic later, but in a little while after refreshing, you will see the tenant, the topic ready to use. I promise. And in the databases, I'm probably, if you go to, again, to your main dashboard, the database, after a couple of minutes, it will be active. You see, now it's all good for me, and it probably will be for you as well. You see, Gabriel is seeing his topic, so it's probably just a matter of a few minutes. So the database is created and active, ready to use. The streaming topic as well. And then we need a very important thing. We need to collect a few secrets that we will later be giving the application to connect to both the topic and the database. I will start with the topic. So I'll go back to my streaming side of things. I click on my tenant and I go to connect. I need two things here. One is the broker service URL. So you see streaming, I choose my tenant, I go to connect, and I'm ready to copy this broker service URL. That is the address drivers will need to connect to this Pulsar instance. There is a handy clipboard icon that tells me copied. So I go to my notepad here and I write me these for later usage. That's not the end of it for streaming. I need also a token because I need to authenticate myself. We are in the internet and not everyone is friendly. You know, you have seen this other tenant that looked like the other tenant looked like a very ill-intentioned kind of person.
Yeah.
So we better
don't show him your token.
We protect ourselves, and that's why your token is a secret. So if you look at this connect page, there is a token manager. Click on it, and luckily, a token has been created for you already automatically, and there is a nice copy button here. Let's copy this. So you click on it, copy it. Nice. Luckily, you don't have to, copy it to type it letter by letter because it's a pretty long string. And there it is. This is my token. It looks like gibberish and it's 500 so characters long. So you just copy it and keep it here for later. And we are done with the streaming part of the secrets. Now we have to do something similar on the database side. So I'm really sure every one of you are ready. So by now you all have your database ready. So let me click on database again. You see there is here my database. It's ready and available. Workshops. I can go to, I have to do two things. One is I need a file that is the Secure Connect bundle. This is a file containing a few addresses and certificates that will enable two-way secure connection. So I have to click to connect tab here. So you make sure you are in your database, dashboard and workshops or whatever the name of your database. Click to connect. You see, by the way, there are very many ways to connect to your Astra database, but we are now choose any one of these connect using a driver. Let's say driver Python. We are actually not concerned with the code snippets here, which are a good start to start writing to your database because the code is there already for you. But what we are interested in now is this download bundle. So click on download bundle and you see there is this Secure Connect bundle. Right? So database, connect tab, connect using a driver, and then you can finally get to your bundle. So the bundle is a zip file and you take it as it is. It is a zip file, you take it and you save it on your machine. And this will contain a bunch of files. You don't care about them. You just take it as it is. It will be used by the drivers to set up completely the connection to your database. You can click any language because the bundle is effectively the very same file. So this is just, it's no importance which language you click here because the bundle you download is the same file. We are not using any of this information. So you just click on these to get a zip file. So you click on Java, but it will not change the fact that the later code will be in Python and Node. Sorry. Okay, so instead of opening this file, you just save it. You save this zip file, and it will be called something like Secure Connect Workshops.zip. Very good. Let me save it. There. And we are almost done. Because alongside the bundle, we also need secrets to authenticate ourselves with the database. And to do that, you can go to, again, you can, for example, you can go to your, you can do this. You see this current organization drop down here. See, which is given, it has your email address here. If you go to organization settings at the bottom, you will be able to access something called token manager. So you see here, token management. Now, important point is that streaming and database are two different things within Astra. So we need a different set of tokens, a different token to access the database that will go along with the secure bundle, the zip file you just downloaded. So you go to organization settings, token management here, and finally you see application tokens. We can generate a new token. Again, all instructions are for you to review in the GitHub repository. We need to create a new token, and it is tied to the role of database administrator. So once you get to this token management page, choose the role database administrator and just generate a token here, this nice blue button. You see, my token has been generated. Very good. So the token is composed by several strings. We are now, what we need now are the first two, client ID and client secret. Now you can and should download the token as CSV to have it stored as a file, because if you leave this page, the token will not be shown again. You can make a new one anyway, but let me copy this client ID. So the first two parts here, client ID and client secret, we will need them later. So let me copy client ID and store it, guess where? So let me call it this db token, db client ID, and I paste this. Now, I am showing my secrets to you, of course, because otherwise it would be hard for me to show what I'm doing. But of course, after this workshop is over, I will go there and delete my tokens because they are now leaked, right? So client ID and client secret are there for later use. For today, you can forget about the third part, token, that's needed for other kinds of access to the database, but we don't care now. So the important thing is that we have, for the streaming part, a service URL and a streaming token. And for the database, we have a client ID and a client secret. And saved somewhere on my computer, I have a file that is probably called secure connect bundle.zip. Okay, so this is, I appreciate this is a bunch of stuff, and this is all the kind of authentication and connection parameters you will need to make your game work. Now I would like to stop a couple of minutes and ask you if you managed to get all of these ready for later use.
This is a good checkpoint, Stefano. We're at about 45 minutes.
Yeah, no. So can you give me a thumbs up in the chat if you managed to have all of these tokens? Because I know it's a lot of things, and I hope I've been going slow enough for you to catch up. Sushant, well done. Vladislav, very good. Okay, so someone is temp mail. Nice name. Psych. Okay, so we have all tokens ready. Great. So streaming and database. Very good. Okay, so let's quickly go back to the slides for a little time and show you a few things. And then we will, so we did all of this hands-on part and we moved to game architecture. So I can switch to big. Us being big again. Yeah, we are big again, David. So, okay, so very quickly, let me review a few parts that made that are part of the architecture of this game. So this is not a professional game that usually requires a whole team and a whole number of months or years to develop. So of course there are some, it is a sketchy kind of game, and you will see why. But still there are a few interesting points, and many more than we can fit, of course, in this workshop. So you are very much invited to go in the README and have a look at the few highlights that we put there. At the moment, so a very broad glance at how the game works. So you already know that there are clients sending messages, so updates on themselves, to the API on the server. The API checks with the local database where the game status is stored, validates these updates, something like, you can't go there, there is an obstacle, or you can't go there, there is another player, or the word ends here. So here is where the actions by the client are validated. You see this balloon here. And in any case, now notice there is, I split the server into parts here. That's to make it clear that there is never a message going directly from the API to all players. Messages that go to all players are always written to the streaming topic first, and then a second independent part in the API picks them up and broadcasts them to all players. Why? That's because we might want to run the API on several machines. So we want to have an independent bus to route messages. So every player gets all updates that are meant for every player. This second part, the part in the bottom half of this server, is very dumb. It just picks messages up from the streaming topic and routes them to all connected clients. And that's it. All of the thinking happens in the top part. And that's where communication with a single client occurs. So a single client, this one on the top, speaks to the API and might get something in return individually. And it is this backward arrow at the top here. The API thinks, validates, makes something happen, and writes and reads from the database, and also usually routes some messages to the streaming topic. These messages from the streaming topic are then picked up by another part of the server and dispatched to all players, all connected clients. That is a choice, and it is a sort of a reasonable choice to make the architecture simpler, if you want, because we can rely on Astra streaming on the Pulsar, underlying Pulsar messaging bus, to properly broadcast and pub/sub all messages around. Okay, so what about technologies? Something we already said. The client is written in React, is a node application written in React. The API is running in Python with the FastAPI framework. Communication between client and server is made by WebSockets, which are a sort of a standard way of keeping long-term bidirectional communication over the web. And that is very much better than the various tentative solutions built on top of the request response paradigm, such as, long polling or whatnot, server sent events and stuff. But I mean, WebSockets are the current standard solution. And the communication between the server and the streaming topic is done with the ordinary Python drivers for Pulsar, because Astra Streaming reps Pulsar in it. Okay, so you are invited to have a closer look at the code later, of course, but let me show you quickly how these messages are made. So events, messages, pieces of data, but what are they? What in this case will go around in the game are strings, but they are actually JSON strings, so serialized JSONs. And the typical exchange of information works like this. The client sends some kind of update on its position. So message type player, and then you see name XY. So the client sends to the API, I am Mark and I want to be at position 13.9 in the game field. The API validates, enriches the message by adding the player ID, because this is something that the API can do with its authority. And then this message is routed to the streaming topic, and then it is just picked up and sent to all other clients as it is. Other clients will receive this message and they will know, oh, Mr. Mark is at position 13.9, very good. And they will be able to update their own representation of the game. So the players, all players connected to this game will see the player, the spider representing the player, being drawn in the right new position. And that's basically how it works, with all sorts of subtleties. So there are actually two WebSocket connections per each client. One is called the player WebSocket, and it is used in both directions for messages specific to that client or from that client. And the other one, the word WebSocket, is just only server to client, and it receives all messages that are meant to be broadcast. So according to what you saw earlier, this is the full shape of how the messages are exchanged. Now, I better go ahead. It's a pity, but we will probably not have time to go much in detail. Again, have a look at the slides. We will be happy to discuss more in detail, because there are actually several kinds of messages going around in this game. It's not only player is at position XY, but it is I'm entering the game, I'm leaving the game. There is a chat feature. There is information on whether some pieces of food is at some position, bricks, walls blocking the way, an initial exchange on the shape of the game field, and so on. But again, you will probably have some fun trying to look at the code and figure out what are the various pieces doing, and that's probably much fun for you.
Maybe
Sure.
a point of performance here. The 7.0 doing a great job of showing you how these messages are moving around, but he's of course using English to do this, and JSON formatting and everything to do that. Behind the scenes with Astra Streaming, it has its own binary format, right? So one of the things that whatever client you use to communicate with Astra Streaming, one of the things that it's going to have you do is convert the message into binary format, right? So the Astra really doesn't, or really Pulsar doesn't really care what the message is necessarily. It just cares about getting those bits to that topic, right?
Yeah.
And vice versa.
Yeah.
So under the covers, though, it's doing that, and there's quite a bit of performance talk around that.
Yeah, good point. And speaking of that, actually Pulsar supports schema-full topics, so you can enforce a schema, which makes for very much optimized communication. And the reason why we didn't do that in the game is that once you start having schema-full topics, you need a different topic for different schemas, for different kinds of messages. So we decided not to make this game overcomplicated by creating several topics, and we stuck to just sending plain old strings and coding JSONs at the application level just for the sake of having a single topic. But of course, if this were a real application, one would think of these and several other optimizations, of course. Okay, so, well, I will sadly have to skip what happens exactly when new clients connect, what kind of a sequence diagram sort of describes the various exchanges between client, server, database, and topic. But you will see that in the slides. The same, unfortunately, I have to skip what happens when a new position is sent to the server. How is validation working? Of course, validation will work by looking at the currently stored game state at database, and then the new player position might have been changed by the API before being put in the topic. And an important remark is that it is very important in an online gaming system that all kinds of validation occur at server side. So you can't trust the client to be honest. Why? Well, have you ever seen cheaters in online games, right? So there is a whole industry of cheating in online games, and they are, broadly speaking, they are based on the client being in charge of some checks that it shouldn't be. So if you move 100% of the checks on the server side, you are theoretically safe from cheaters, except very corner cases. that is a hard lesson that in the very first online games was not yet very much known. And I remember those of you who played Diablo or other first wave of online games remember the hordes of cheaters that were roaming around and making the game unplayable. But maybe Diablo is not much younger than the console of the 80s, so maybe I just keep my memory and go ahead. Okay, so I would like to go in detail about this point, but yeah, I have to spend one word on this. Validation means that the client constantly sends a tentative new position for the player and it gets it back, either confirmed or changed by the server. So let's say you see in this example, the client will send position 0, which is valid, and it will get back, yes, you are at 0. Then it moves to 1. Position 1 is valid, yes. Then it goes to 1. But then for some reason, the client tries to go to position -1, which is, let's say, out of the boundaries of the game field. The validation fails, and the message that it gets back is 0. So you can't go beyond the borders. And so you stay at 0. Now, this is all good. And it is exactly what we were saying. So validation at server side. But then, don't forget that all of this is asynchronous. So while the message to the server has been sent, the client might be doing something else. So it might be start to jump between 4 and 5, 4 and 5. But then something terrible might happen. The client was at 4, and then it jumped at 5. But in the meantime, the validation of position 4 has not yet reached the client back. But then it arrives, and then the client was at 5, but then it gets, you are at 4. But in the meantime, the validation at position 5 came in. And so the client says, oh, I'm in 5, but then I'm in 4. So it's very easy to, when it's about asynchronous communication between server and client, it's very hard to think everything through. And you might end up having this kind of infinite loop of stale updates flowing back and forth. So a solution to this particular problem is to add a generation number to every message from the client in order to decide whether a message is old or is too old, and then it will be discarded. So you see, once introducing a generation number for updates, this number 4 here, the one below the cross, once it reaches the user, it will be too old to be counted, and it will be simply discarded. So this is a simple example of how to cope with asynchronous communications in the right way. Actually, a professional level game would do something much more advanced. It will do some kind of a speculative client-side guess on what is a valid move to give the client the idea of a fluid experience while still relying on confirmation from the server. Of course, this requires a careful studying and also careful engineering of the game, which is very much out of the scope of today, but you get the point. So we had to introduce this generation number to make sure we are not following validations that are made too old by something that occurred in the meantime, basically. Okay, so with that, how are we doing with the chat, David? I see.
Good.
All good?
Everybody seems very happy.
Great.
Nobody
very
hates
good.
it.
So it's time to start the game. Now, let me go again to the repo, and I'll jump to load the project into Gitpod. Now, you see at point 3, you see this nice button open in Gitpod. I suggest you to open in new tab like I'm doing. If you open that in new tab, a new tab will open, and you will be asked to authenticate with GitHub probably, which I'm now doing. Everything should occur out and everything. Okay, so now Gitpod is starting. What is Gitpod? So first click and then we speak. So it goes while we speak. So what is Gitpod? Gitpod is an online development environment, is an online IDE based on VS Code. But maybe I better switch to small heads. And there we go. We are small again, David. I'm sorry, but we have to show a lot of stuff.
Getting used to
So
it. Getting used to it.
okay. So the Gitpod button opens a new IDE as a browser window for you, and it clones the repository for you in your own copy on a machine in the cloud, ready to be played with. And you can see more details, but basically in the Gitpod button, you see there is a file browser on the left, a preview editor window on the top, and a couple of consoles at the bottom. Actually, there are 3 consoles on the bottom, and the important ones are the one you see on the lower right, you see a console switcher. There is a console called Setup API, and you recognize it because it's a API ready to start, which is a lie. And then you see a setup client, which says client ready to start, which is true. So this is just, you can think of this Gitpod tab as a virtual machine with 2 consoles open, ready for you to start client and server in your own copy. But before starting them, we have to make sure everything is able to connect to the streaming topic and the database. So we start doing that. And to do that, okay, maybe we can here. So it's all explained again. So in the repo, you see a few more details on how the Gitpod interface is structured, but we go over and we have to do the API setup. So everything to make the API run is contained in, is basically 2 things. We have to make sure we give this secure bundle to Gitpod, so to this virtual machine containing everything. So we have to upload this secure bundle over to your Gitpod. To do that, let me find my secure bundle that I downloaded earlier from Astra UI. You see it here, Secure Connect Workshops. And now the magic happens. How do you upload a file from your local machine to Gitpod? You drag and drop. You see, I'm dragging this bundle and you just drop it in the main File Explorer column here on the left. And there we go. You see the file is now here. That means it has been uploaded to Gitpod. And as far as the bundle is concerned, we are almost there. In the meantime, and make sure you are in the API console, the one that says API ready to start, we have to create an environment file with a few variables. You remember the streaming secret and the streaming service URL and the database secret and the database ID. We have to put them here. So there is already in the API directory, you see there is a env sample file, which is a blueprint for the environment file. The best, so maybe it's a bit too small. I can try making the text a bit bigger for you to read. Maybe that's better now. Can you read? Sidiculous, the repo is cloned automatically for you as you open your Gitpod instance. So the Gitpod instance just creates a machine and clones the repository ready for you to use. So no need to do anything manually. You should end up with the repo already cloned in your virtual machine in your IDE, ready to use. So once you click Gitpod and wait a bit, you should just drag and drop the bundle and then do what I'm going to do now, which is so make sure you are in the API directory here. Then you can copy the env file. Sorry, you copy the sample file .env.sample as .env. Again, this is all spelled out in the repository. We are at point 4a, so please use that as a reference. I am copying msample as a new file.env, and I open it, gp open.env. Actually, you can just find it on the left and click on it here in the file explorer. That's very easy. You see this environment file, it defines a few variables that this is okay. It defines a few variables that we have to change to reflect your own settings. So the tenant, you remember that I copied all of them here. So this is my tenant and it's different than yours. So you go here and instead of this, you should keep the quotes, but you see I'm replacing streaming tenant equal my own tenant. And I'm just doing the same for broker service URL. I'm copying it from my machine, let's say from my notepad, and I'm pasting it in the .env file in Gitpod. Then after the streaming service URL, I'm also doing the same for the very long token string. Now be careful not to copy spurious space characters or new lines or anything. It has just to be exactly that sequence of characters. And there we go, it's very long, we don't care. This is okay, unless you are running locally. Yes, something that I didn't say enough is that you can do without Gitpod if you want. You can run locally on your computer, but then you are on your own. So you will have to make sure you know directories and you know what to do. Yes, so okay, Gabriel, I have made a copy of the env sample. I copied it as env. And then I'm starting editing this .env file with the actual values I have for tenant, service URL, and streaming token. Yes, you can edit later because it's just a file. It's just a file that will be read once you start the API. So you can edit it later and just restart the API if you get some problems. Yes, as Alex says, thank you. There are detailed instructions in the repository, so it should be good. Okay, so in the environment file, you set the tenant for streaming, the service URL for streaming, the token. This is okay as it is, especially if you're on Gitpod. Then namespace and topic should be good, unless you were fancy in naming stuff. But I suggested you to keep it okay, to keep it as a default as suggested. So you should be good. And so far, so good for the streaming part. That's all set. By the way, I think Gitpod auto-saves, so there's not even need to Control S anymore. And now let's move to the database part. You see, there is a second part in this same env file that is about Astra DB. So you should make sure this is the full path to your Connect bundle, and it probably is. The best way to check is to do an ls workspace workshop star zip or whatever, and you should get an output telling you, oh yes, this is exactly the full path to my bundle. Again, this is something you see in the repository, so in the README it's all spelled out, but just for the sake of it, I did my ls to check, and it's all good. And then I have to paste my username and password, that is DB client ID and DB client secret. So let me paste those as well here. 1 and 2. Oh, here we go. 1 and 2, and there we go. Now, again, the key space should be all good unless you give a different name. So make sure it is what you think. And with that, the end file is ready. So I'll give you a minute or so to keep up. So make sure you copy the env sample to a fresh env file, and then you go through the variables that are defined there and make sure they match your own secrets, credentials, tenant names and everything. Once you have everything in place, you should be good and you should be able to start the API. David, you wanted to say something?
Yeah, so as everybody's catching up here, kind of an interesting point. If you would scroll up there, notice the address of the Pulsar server, your Pulsar instance. So Stefano's using Pulsar plus SSL as
good point.
as the
Yes.
protocol, right? You could also you might see a persistent there. You might see a non-persistent there. So this is obviously very specific to Pulsar, and it's not necessarily the protocol, but it's a way to signify the topic that I'm connecting to. How is it expecting interaction, and is it going to save the messages, or is it just purely in memory? That sort of thing. A deeper topic for sure to talk about, but just kind of a nice thing to notice about what Pulsar does and what kind of niceties it gives you.
Yeah, good point. Okay, so I think we can go ahead. Let's assume your M file is ready, and if everything is good, you should be able to run the API as I'm doing. Uvicorn API :up. So that maybe is worth highlighting. So let's say you have set all of your variables in the M file, you uploaded the DB secure bundle, and you also made sure the database part of the secrets is okay. So username and password for Astra, and then you can start the API. If everything works, the API will start in a couple of seconds maximum. Okay, so we already saw this error. I think that should be connected to some Python specific mishandling of timestamps, but in our experience, if you start it again, it will work. And there we go. Okay, very good. So the API is up and running. And if we had more time, I would jump to the database and show you what is in the table, because as the API starts, it creates a word for you with a few things ready to be visited. And you will find in the README how to go there and check what is in the table. But now let's stick to the game, of course. The API is up and running and is waiting for connections. And then we move to the client. So you remember this console switcher on the lower right of the Gitpod? Click on Setup Client. Luckily, the client will not need any secret because it's just a client. Doesn't need to access streaming directly, database directly. It just needs to connect to the API. And we didn't build any authentication in the client server of this game. So everybody can connect, no problem. And to start the client, I can do npm start as any well-behaving React application. So this is being started and magically, there we go. It should all work. And there we go. Okay, so before I'll click enter game, some remarks. This is, sorry.
Quick question. Yeah. Do I paste the game server name? So once you did the npm start, it brought up the browser with the address, right?
Yeah, so there's a bit of Gitpod magic going on. Good point. So Gitpod is able at intercepting a few things that happen behind the scenes. It does address translation, port translation, and it does a bit of dirty things behind the scenes. So as soon as it detects what in a local setup on my machine would be localhost 8000 something, is actually translated to a very funny thing here. Was that the question, I guess? I
think so. There's the magic behind the scenes,
yeah,
I think.
Okay. So most of the magic is handled by Gitpod. If you run locally, you find all instructions in the README. Now, trust Gitpod, trust us, everything works. And if you want to open this game window in a different tab other than the Gitpod, and you are very much encouraged to do so to see the full screen game, 1 second, Rugs, because otherwise we lose control. 1 second. You can go to the first console. This is again spelled out in the repo, and you should be able to run gp url 3000, which will give you the full link that you that everyone can open. And so this is now an internal mini browser in Gitpod, and it is good enough for 1 second, but later we will move to the real thing, of course. But this can be opened also in a different new actual browser tab or window. And in particular, we configured this Gitpod to make these ports available also for from outside. So from you guys at home who are following us, watching us. So that later we will try to have many of you on board on the same game. But let me just show you very quickly one thing here. So I'm ready to enter the game, and everything is pre-compiled for me, including a random spider name. I'll stick with Eratigena, who is one of my favorite spiders, one of the scariest and biggest in Europe, but completely harmless. Let me make this clear. So if you click enter game, a lot of stuff happens, right?
Stefano,
Yeah.
Wait a minute. There is no such thing as a harmless spider.
Yeah, okay. Come on, they are not even able to bite you.
I know we're going to go a different direction, but a huge spider is not a harmless spider.
Okay, I get the point, but it is a matter of taste. It's actually Eratigena is one of the friendliest who are there, even though it's one of the biggest, but still hairy legs and all that. I have to say. Anyway. Okay, so you see, everything worked. Apparently, this is my spider here, and if you click, so you can use these buttons to move your spider around, but if you click on the game area, you will be able, I'm now using my arrow keys on the keyboard. You see, there is a spider going on, there is a wall I can't go against, and there are flies, and if I eat the flies, I get a congratulations message from the API, and the fly has moved to some other location. So this is the game. Of course, this is a multiplayer game, so I will show that to you by opening a new tab with my URL. Now I am Argiope, one of my other favorite spiders ever, and see there are, now I'm not good at Windows, so I'm not sure how can I go and make the two. Maybe this might be just enough. So you see I'm now moving one of those, and through the magic of streaming, the messages are flowing to every other connected client, and the position of Argiope is moving also in the other client.
That's pretty cool.
There is also a secret way to have your spider express some love here, and then you can't go against the other because there is collision detection and all that. Now, I hope many of you were able to have your game running, but let's try and share my own address, and let's see how many managed to get on board. I have to, so you can try joining here just for the heck of it. Let's see how it works. I see a few of you, and there we go. So Eratigena is actually a ghost there, but I'm eating, you see, can you? Hello, I see a lot of people, and now it's more or less working. Now, okay, while we move around and have some fun eating flies, as anybody's idea of fun might be, this is a bit clunky, and I know why. So we've been doing a bit of testing recently, and you might see the game is not as fluid as it might be. Let's say this is probably not an ideal gaming setup. The reason is that we have no control over where physically this Gitpod machine is located. And imagine that every move by every player will need to read from database. So if you have Gitpod in the US and the database in Europe, every move will need a lot of back and forth across continents. So that's why it might look a bit clunky. Of course, in a real professional gaming setup, engineers would make sure the database and the streaming and the API are all co-located in the same region, in the same availability zone or whatever, which is what would kill latencies. So now if you're seeing some latency, it's probably because of that. And if you might want, now let me, I closed this client, but no problem, because you see it's the API that counts. While you move around, let me just show you that in the README, you find instructions to seamlessly jump from using AstraDB as the backend store to using a local in-memory set of variables that pretends to be the database, just for the sake of testing the game without the latency that is artificial, if you want, because it's induced by, you don't have control over Gitpod. So if you have everything, if you are in control of your infrastructure, you would make sure the latencies are low. Now, while we are at it, I think I've been logged out, unfortunately, but now I think we have a couple of minutes.
It'd be interesting to see the stats here, the Pulsar stats of how much information is getting passed around.
Yeah, that's exactly. So that's why I wanted to go here. Let's see, we might still. So you see, if you want to later have a closer look at the README, there are all kinds of instructions on how to actually also hack the system, because you might try going to negative positions, and then you would see this mechanism of validation at work. You remember the one we briefly saw. But a cool thing you can do is you can actually have a privileged eye over what's going on in, so you're still moving, very good. My spiders are moving. So you can click on the streaming tenant, the topic, and there is also a very nice try me button. Try me button is basically a development aid that makes it possible to see what is going on in the game. You see, you are moving, and I'm seeing you move around. Let me stop this. Maybe I can. No, if I disconnect, everything disappears. No matter, no problem. So you see, there are. Now it's you're moving too fast, but you see what I mean. If you try writing in the chat, if you try eating a fly, if you try going against a wall, you will see every message corresponding to these point-like updates. You will see them here, because this is an interface that lets you surreptitiously attach to the topic and secretly eavesdrop what's going on in the game. And actually, a very cool thing that you can do is you can create a phantom brick, because we have the secret privilege of being able to paste a fake message. You maybe have seen it very fast flowing by. And in the game, a new brick has appeared. And now if you look at the upper left corner, you will see me going over a brick. Why? Because that brick is not real. The server does not know of that brick. It is just something that I faked. I injected a fake brick to all clients, but the server never created that. Okay? So there are a few suggestions on how to try and hack the system in the README. Maybe I think we risk running a bit late. So I just want to do a very quick thing. I see everyone having lots of fun with your spiders. Of course, once you set up your own instance of the game, please invite your friends, your family, and have a long, I wish you long sessions of playing. Now, I will just mention that Astra interface here lets you also query the database directly from the browser.
So, hey, Stefano, I want to call out Seditious. Mention some streams let you rewind the stream even when it is live.
Yeah, right. So you can do that with the reader interface, right?
Well, what I was going to say is Pulsar has the notion of a cursor.
Yeah.
Right. And so this one kind of got my attention is so if you did hook up persistent storage on the backside of your topic, and we got to do a little bit of configurations, pretty simple though. What Pulsar is going to do is save all the messages, right? When everything is acknowledged, it's still going to save all the messages, right? And kind of back to that CQRS idea, someone then can go into the storage and replay this entire game because all the messages with their timestamps are in order. And then, you know, whatever your data science team or whomever could come back and replay the entire game because we set it up that way. I hope that, Seditious, I hope that answers your question.
You know, David, I just came up with a very good idea. Advanced homework, write a program able to replay a game. Why not? Okay, that would be maybe too much, but that might be a good
I didn't know there was going to be homework.
Yeah, there is. Anyway, there is, but it's simpler. Still, it involves some coding, so it involves a bit of understanding of the code. We didn't have time to go much into the details of how the code works, but it's all spelled out and explained. And I think the important thing is to convey knowledge of the underlying infrastructure and the general architecture of the clients and the server, especially of the server. But the homework will be more, we'll give a bit more, the homework instructions give a bit more details. And of course, you are free to reach us on Discord and to discuss homework and whatever. Just before we close, let me show you that you can look at the database. So it's not, let's see, kind active XY. I think that should work. Yes, you see. Oh, maybe we can also ask for name. Why not? So this is the current status of the table. You see, these are the players and they are at a given position. And then there are objects of kind food, which are the flies. And there are objects of kind brick. And everything is there in the database, persisted, because this is now we are watching the database. But as much as we are having fun, I think that we have to stop here, and I'll just I'll leave my game working and running still, but I have to switch back to the slides for let me quick gloss over a few additional topics that you will find in the slides, and let's
but Stefano, the competition is real, as Ali said, and they want to know who's winning.
Well, the nice thing is that I haven't had the time to implement a counter of the flies.
Oh!
So, advanced homework, please add a way to compute for every player the amount of flies that have been eaten, and make sure you are safe against cheaters. Okay, no, I think you can think how that should work. Okay, so the code to see the positions, Gabriel, you will find in the GitHub repo. You will basically reach a console in the Astra database interface, and you will find in the repo the few commands to run select queries on the database. Mind that it is not a relational database, so even though the syntax looks a bit like SQL. It is actually a very different database. It is a NoSQL database. And I mean, we could speak hours about Cassandra, and we actually do very often, but now it's not the time, I'm sorry. So please reach out if you're interested. We run other workshops, and there are a few pointers in the README, but it is now, we are running a bit late, so I have to stop here. I hope you enjoyed the spiders, and now a bit of closing words. First thing, the quiz. I hope you are still connected to Menti. You will, so very welcome to reach us on Discord, Gabriel, and we will also accept pull requests, as Alex said. So I hope you are still connected to Menti because it's time for the quiz. So maybe we can give you again the link. Now, there are a few questions here, and compared to the initial questions at the beginning of today, this time you have to answer correct, but also to answer faster than anyone else. There are no flies to catch, but there are answers to give fast. And once you answer fast, you will be eligible and win some nice prizes, some nice swag. So please join us on Menti and enter the code you see here. I will make it also visible here, and I will try and disappear again with my magic trick. Okay, so probably many of you have were already connected from before, but since this is a very important part of today, so we are giving out prizes, so we will wait a little more.
Now it got real here.
Yeah.
Stefano, it's swags on the line.
So it's nice that we got a lot of ideas for new homework. We will make them into new requirements for the homework. Very good. Okay, so I hope, oh, sorry. I mistakenly made us small again. Okay, so I hope you were able to connect. Let's see. I see maybe a few more of you could join. Let's see. Okay. Okay, I see some of you is joining. Okay, so let's start with the quiz. So be fast and be correct. Okay, so let's wait for everyone to join, and I remind you, write your answers. So type your answers in Menti and don't look at YouTube because there is a few seconds delay and you would lose in an undeserved way. So get ready, and there we go. Question number 1. Answer fast to get more points. So the database we created today is called AstraDB, is in the cloud, is called Workshops. Database? What database? So let's see, I hope you all followed along when we were doing the hands-on. And time's up. It's called AstraDB, right? Is in the cloud, right? It's called Workshops, in another sense of database, yes. So very good, all of you. Nobody got it wrong. And let's see the leaderboard. You know, okay, so not yet very much difference. Noctua is the fastest, and let's move to the next question. You know, the previous version of this workshop did not use a database. It was a very limited game with just spiders moving around, no obstacles, no collisions. So I didn't change the question, but just I flipped the wrong and right answers. You know, that was pretty funny. The correct answer was what database, but now it's the other way around. And then next question, question number 2. Answer fast to get more points. I like tricky questions. Today we use the messaging pattern PubSub, shared queue, failover, or exclusive. I think David might recognize at least all of them, in particular the 3rd and 4th.
I don't think I'm allowed to answer these, right?
No, time's up anyway. So we've been using PubSub. Yes, so PubSub meaning that all messages get routed to all connected clients. By the way, shared queue, we mentioned that it is a shared queue, and failover and exclusive are specific ways of handling specific situation within Pulsar. So let's see how the leaderboard is, and we got a wrong answer. It looks like Puffy jumps to 1st position, Noctua 2nd, and Subham 3rd. Okay, but still everything can happen. So there are still 5 questions to go, and there we go with question number 3. Answer fast to get more points. Messaging platforms cannot be in the cloud. They decouple sender and receiver. They are always schemaless, and they are for data in motion. Choose the right answer. And time is up.
These are tricky answers.
Yeah, but I see many of you choose the right answers because messaging platforms can be in the cloud. And indeed, today you saw an example. They decouple sender and receiver in general. They are not always schemaless. And they are for data in motion as opposed to data at rest. So they are focused to optimize dispatching and routing of pieces of data. Okay, so leaderboard. I see Alex jumps to 4th position. Is that Alex? Who knows? Anyway, Puffy stays on 1st position, and there we are with question number 4. It's that Alex. Okay. So data reaches the clients, let's see, directly through Astra streaming, or through WebSockets, or with client-initiated requests, or the client only sends data. So what is the right way? This is part of the architecture we've been showing you today. And the answer is through WebSockets, not directly through Astra streaming, because there is an API layer between, and for sure not with client-initiated request, because we are not in the 80s or in the 90s, let's say. The client only sends data is wrong because the client receives data a lot. Otherwise, it would not be able to update its own representation of the game world. So let's see what changed in the leaderboard. The fastest is Luca, who jumps to 2nd position. So Fosco, Luca, and Subham, position 1, 2, 3, very good. But there is still room for any change, and there are 2 questions to go, or 3 questions to go, and let's go with number 5. Get ready. We introduced generation in messages to know which clients writes them, or to have a unique ID for storing them, or just for better debugging, or to ignore old updates. So why did we introduce generation in player messages? Let's see. And time's up. So, I see a lot of wrong answers. So we did not have generation to have unique ID for storing them, but to ignore old updates and to make sure we are not caught in an infinite loop of spurious updates from the past. So this might have a good, devastating effect on the leaderboard. Indeed, I see we lose a lot of points, and Fosco, Salman, and Noctua. So Fosco, the fastest and the leader so far. Okay. Now, these are the last questions, and yeah, let's see. Everything can happen. Oh ho ho. Answer fast for the second to last question. Chat data and player position data have a dedicated streaming topic each, or they use the same streaming topic, or they do not pass through streaming topics at all. I remember we made an explicit remark on this fact. Let's see. So even here, I see many wrong answers, but yeah.
This is going to separate.
So we created a single streaming topic for all kind of messages in the game. That was a choice for a sample game. Probably in production, I would think of carefully about creating several topics. But in this case, we just wanted to keep things simple. So a single topic for every message.
By the way, Rags needs a little bit of Jeopardy going on in the background as we're waiting for the answers.
Right. Sorry. I always forget about music, and it's never too late. There we go. You should be hearing some music, at least for the last part of today. And the last part it is because it's the last question. So everything goes here. Anything can happen. In this game, some messages never go through Astra streaming. Is it true or false? I think we could have stressed this point more, but there were a few sketches in the slides, and the time is almost up. And this is true. There are messages that never go through Astra streaming. They are direct client to API and API to client. And those are the messages that are not going to be broadcast. Wow, looks like this was a very hard quiz. And well, this is one of the ways you learn. But wow, it's really been a huge change in the leaderboard, and we have a winner. Noctua is a winner, Fosco and Iker second and third. Very good. Yeah, tricky. I know. I like to do hard questions in the quiz. Sorry. So, congratulations to the first, second, and third, and to all of you. But in particular, the first three positions, Noctua, Fosco, and Iker, win a swag. So please write an email. So first take a screenshot of this winning screen on your phone or your browser. Take a screenshot and then send it to garyharvey@datastax.com to get your swag sent to you. But congratulations to all of you, of course. And I hope I've given you enough time to get a screenshot, because now I have to move on and go to a last slide in the quiz that will just be left open. If you want to give us some free form remark, suggestion, or complaint, you are very much encouraged to do so now. I will keep the Menti open, but in the meantime, let me jump back to the actual slides, if I find a way to do that, because we have just a few closing information for you. Okay, so how to connect to Gary to get your well-deserved swag? You know that. Maybe I can... Shall I leave the music on? Yes, why not? So this is now the closing part, so why not? Okay, so homework. There is a form linked in the GitHub repository to submit the homework. That will require a couple of questions to check for comprehension of today's topic, and a screenshot of your working changes to the code. There are a client-side and a server-side change to be done. They will be explained in the repo. Anyway, they involve changing the color of the name next to each spider, and also have the API send a welcome message to every player who connects. So go ahead and have fun with that. Then, I've seen a question in the chat. Is this a weekly, do we do weekly events? Yes, we very much do. We basically run workshops every week, and this is a glance of what's coming in the next few days. So we have an introduction to NoSQL Database, which sort of integrates the very little I could say about Cassandra. Maybe I can remember the command. That should be this one. There is a whole link. Okay, so Enrico, maybe we can find a way. Okay, so maybe someone might help Enrico in the chat with his first, second, or third position. Anyway, these are our next events, and please stay tuned with our page to be informed of new events coming on. Then there is an important special announcement. There is a hackathon that is about to start, and that's sort of a long-term kind of event, because that's a hackathon that starts in February and ends in May, and that's thought to be, something that goes along with your daily activities. And in particular, well, there is quite some actual money involved, so you can have up to 40-something K in prizes. Sorry about that. You can have, please go ahead and register. You should have the link in the YouTube chat. So there is there are a series of challenges that will be progressively released in month by month. More information in the link that you find, and in particular, even more information in this Friday. So in 2 days from now, there is a sort of pre-event workshop where you will learn more about what you will do and how. So again, you should find the link in, maybe someone is able to send the link for this particular event, which David is now hiding, so I will switch to the small the small heads. Now you can see all of them. Okay, so well, closing words. Please join us on Discord, because that's where the discussion goes on. We have a full Discord server, very lively and full of channels about everything, AstraDB, streaming, Cassandra, development, and so on. So we are very glad to help you, and also in practice for the homework submissions and every practicalities also, you should reach us there. What else? I hope you liked today's workshop, and if you were a first-time visitor, please click on that thumb up, because come on, you stayed with us 2 hours and more, so we would like to see a thumbs up going up a bit if we deserve it. Otherwise, go away. I'm joking. So okay. Wow, the numbers are going up a lot. Thank you. Yeah. Okay, so I think with that, that's it. I hope it's been fun and you've been having fun with spiders. I hope you are not arachnophobic too much, by the way. That might be a risk. But besides being fun, I really hope you learned a lot and you will be able to put what you learned to use. We would love to see what you can build with your new knowledge. And so that's even another reason why you should connect with us on Discord. So with that, thank you for being with us so far.
Thank you. Thank you, everybody. Stefano, thank you for putting this on and putting everything together.
Thank you for the great
a lot of preparation.
live. And thank you all, and goodbye. See you.
See y'all.
And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming workshops.
A being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats.